Welcome to the DIY Honda Garage channel. DTC P0851 refers to a malfunction in the neutral position sensor A circuit, indicating that the output voltage from the sensor is lower than what is typically required. This diagnostic trouble code, DTC, is particularly significant as it alerts the powertrain control module, PCM, to an abnormal reading, leading to the storage of this specific code. The neutral position sensor is a critical component located near the transmission, where it monitors the position of the transmission. Its role is essential, as it ensures that the engine starts only when in the neutral or parked position, thus preventing accidental movement. A low voltage condition in this sensor can affect engine performance and safety, making prompt diagnosis and repair necessary. This slide presents an overview of the error code's relevance, associating it with the Honda Civic model from 2022 onwards. In DTC P0851, the neutral position sensor is the primary component affected. This sensor is located on the transmission, responsible for determining if the vehicle is in the neutral or park position. It plays a crucial role in communicating with the powertrain control module, PCM. The PCM uses this information to enable or disable the engine start function, ensuring that it operates safely. The voltage output from the neutral position sensor should typically be at a specified value, which allows the PCM to determine the operational state of the transmission. If this sensor's voltage drops below the threshold defined by the manufacturer, it will trigger the DTC. The PCM also monitors this signal, making its role vital for optimal vehicle operation. Understanding the locations and functions of these components is essential for effective troubleshooting. The possible causes for DTC P0851 include a faulty neutral position sensor, bad wiring or connections, and a malfunctioning powertrain control module, PCM. A faulty neutral position sensor may be unable to provide the correct voltage output due to internal failure or wear. It is crucial to assess the connections to the sensor as well, as corroded or damaged wires can impede proper signal transmission. The PCM, which interprets data from the neutral position sensor, could also be failing to process the signal correctly, leading to a low voltage reading being stored as a DTC. Each of these potential issues should be thoroughly tested during the diagnostic process to effectively pinpoint the root cause of the low voltage condition. Symptoms associated with DTC P0851 may include the engine not starting, illumination of warning lights on the dashboard, and potential shifting issues. If the neutral position sensor fails, the engine may not receive the signal that it is in a safe position to start. This prevents ignition and can be frustrating for the driver. Additionally, warning indicators related to the transmission or engine systems may illuminate, alerting the driver to a malfunction. In some instances, the vehicle may exhibit abnormal shifting characteristics, where the transmission hesitates or fails to engage correctly due to the PCM receiving incorrect input. These symptoms can significantly affect the driving experience and necessitate timely inspection and repair to restore normal function. In the first step of troubleshooting DTC P0851, the vehicle should be turned to the on mode, allowing systems to power up for initial checks. This is vital as it provides the necessary power to the neutral position sensor and the PCM for verification of output values. It is also essential to inspect the connection of the neutral position sensor. A secure and clean connection is crucial for the accurate transmission of voltage readings. Any loose or corroded connections can lead to erroneous low voltage detections. After ensuring the connection is firm, monitoring the HDS Honda Diagnostic System for the neutral position sensor 1 value becomes the next logical step. This value should ideally read around 5.0 volts under normal conditions. Observing this voltage reading can provide immediate insight into whether the sensor or an alternative component is at fault. The second step involves jumping the neutral position sensor terminals within the 4P connector to facilitate testing. By connecting terminal number 1 and number 3 using a jumper wire, you're essentially bypassing the sensor to check if the circuit functions normally without it. After establishing the jumper connection, the vehicle should remain in the on position, and the HDS must be monitored once again. Under normal circumstances, the HDS should indicate a voltage reading of approximately 5.0 volts. If this reading is confirmed, then the sensor itself is likely faulty and must be replaced. Conversely, if the reading is still abnormal, the issue could lie further within the related circuitry, indicating possible additional testing is required. This step is important as it narrows down specific components that may need repair or replacement, enabling efficient troubleshooting. In the third step of troubleshooting DTC P0851, the focus shifts to inspecting the VCC1 and NSS1 circuits for any signs of faults, particularly checking for open wires. Before disconnecting any connectors, the SCS service connector switch should be jumped with the HDS, ensuring that it is in the off position for a minute or more to prevent PCM damage. The neutral position sensor's 4P connector must be disconnected alongside the PCM connector E80P. Now we assess for continuity. Both VCC1 and NSS1 circuits should exhibit less than 1 ohm of resistance in their connections. High resistance could indicate an opened or damaged wire, which is a common source of low voltage readings. Inspecting for shorts to ground is also crucial, as a short could lead to incorrect voltage signals being sent to the PCM, necessitating a thorough verification of these circuits during the testing process. The fourth troubleshooting step entails checking for any grounding issues or performing integrity tests on the ground connections. The integrity of ground connections can significantly impact the performance of electronic components in the vehicle. If the VCC1 circuit or the NSS1 circuit can't provide proper signals, it is essential to evaluate those grounds thoroughly. Following this, if previous inspections revealed normal conditions in the circuits and connections, then the last area to inspect would be the powertrain control module, PCM, itself. The PCM can malfunction, causing it to misinterpret signals, which could result in DTC P0851 being stored. This step highlights the methodical approach to isolating issues and reinforces the idea that if all other parts check out, then the electronic brain of the vehicle may need diagnostics or replacement. Final verification is a crucial stage in the repair process for DTC P0851, as it determines whether the issue has been successfully resolved. After performing necessary repairs, such as replacing the faulty neutral position sensor or fixing circuits, it is imperative to conduct a thorough test drive. During this drive, the vehicle's performance should be monitored closely, especially regarding starting conditions and transmission operation. Once satisfied that the issue is resolved, the next step involves using the HDS to clear the DTC from the PCM. Clearing the code will not only reset the system, but will also allow new data to be recorded if the problem has genuinely been rectified. Post-clearance, it is advisable to rescan the vehicle for DTCs to ensure no new issues arise, confirming the effectiveness of the interventions made. Preventive maintenance plays an essential role in mitigating future occurrences of DTC P0851. Regular inspections of the neutral position sensor and its connections can identify early signs of wear or damage, helping to catch issues before they escalate. Additionally, periodic evaluations of the wiring associated with the sensor, such as the VCC1 and NSS1 circuits, can pinpoint potential vulnerabilities like corrosion or fraying that could lead to electrical faults. Ensuring these components are free from dirt, moisture, and other contaminants will prolong their operational lifespan and reliability. A proactive maintenance strategy not only enhances vehicle safety, but can also significantly reduce the likelihood of diagnostic errors occurring. Educating vehicle owners about the importance of these inspections can foster a more informed approach to vehicle health. In conclusion, DTC P0851 signifies that there is a low voltage reading from the neutral position sensor, which can severely impact vehicle operations and safety. It's crucial to follow a systematic troubleshooting approach to identify and rectify the underlying issues efficiently. By evaluating the sensor, related circuits, and establishing the functionality of the PCM, one can narrow down possible causes effectively. The steps taken not only help in resolving the immediate problem, but also pave the way for preventing future occurrences through diligent preventive maintenance. Understanding the implications of this DTC and addressing them promptly contributes to safer driving experiences and sustained vehicle performance. Please like and subscribe to the channel. See you next time.